Okay, so this is the last topic in the trig unit, which is called the cosine law. So this time I'm not going to derive anything, and you don't have to know the come about or the formula. You just need to know how to use it. That's all you need. So let's quickly look at the formula sheet here first so that we know what it looks like. So I'm going to check this is the sine law. Sorry, this is the cosine law. Alright? And there are two versions of the cosine law, this and that. If you manipulate this, you can get this. Or if you manipulate this, you can get that. So you don't have to memorize any of these at all. These two, one last time, are the same thing, except this one, if you use this format, it will give you the length of a side, if that's what you are looking for. If you use this one, that can give you an unknown angle. So you can find an unknown angle using this. So check. Now you know everything for the trig unit. All this SOHCAHTOA, sine law, cosine law. You might be wondering, Math 10C last year, you learned the SOHCAHTOA. This year, in the last two lessons, we talk about the sine law. Why bother learning another law? Check this out. The cosine law allows us to find unknown angles and side in any type of triangle. So that means even if it is not a right angle triangle, never mind, you can still find an unknown side or an unknown angle. Not just that, this is even more useful, more powerful than the sine law. So this one we're talking about today, the cosine law, is used in the following situations where the sine law will not work. Okay? So you don't have to memorize this. If you can't find anything using SOHCAHTOA or sine law, then maybe it's a good idea to use the cosine law. Okay? So here we can find the side opposite a known angle contained by two known side lengths, like this. Let's see if this is 14 units, this is 20 units, and this is 25 degrees. Then you can find the length of this side. Remember, for sine law, you need to know two pairs of length and angle. So angle and a length, angle and a length, angle and a length. Do we know any of these angles? Nope. So definitely we cannot use sine law, but if you use the cosine law, you can still find something. Alright? So second scenario, we can find any angle when all three side lengths are known, like this. We can find any angle here, here, or here. So this is definitely not possible with the sine law. Okay, so now if you look at this, for any triangle A, B, C, here is the cosine law. So I will check off the two versions of the cosine law. This one to find the length of a side, this one to find an angle. Alright? So some tips to share with you guys. Note that sides A, B, and C, A, B, and C are completely interchangeable. So here we drew the angle A here, and B and C. You can put A here, B here, C here. So it doesn't have to be A always at this spot, B this spot, and C this spot. Okay, when solving for psi, consider that psi to be A. Because if you look at this, you just plug in numbers here, 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 and here, then you can find your unknown psi. Okay. Next, when solving for an angle, considering that angle to be A, like this. So if you're trying to find angle A, whatever angle you're trying to find, call that angle A, so that you can just plug in the other given information here, 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 and here, and then solve to find the angle that you are asked to find. The only problem I can think of for some of you would be that if you look at this formula or this formula, well, this one is not that bad, but this one, the math is a little bit tedious. Okay, that's the only problem that I can think of for some of you. So now let's work out this question together. So find the missing side length, which in this case, you know the length of this side, you know the length of this side. The only thing missing is this. So that means you are looking for side length S. If you want, you can call that something else, not a big deal, because I'm going to call it something else because, well, let's look at which formula we should be using first, and then we can determine the notation. So if you look at this not right angle triangle for sure, so we cannot use SOHCAHTOA. Can we use sine law? Well, if I were you, whenever possible, use the sine law. Why? Because it is simple, nice and easy. Can we use that? Look at this. We have one angle. We don't know the given sine. That's fine. But let's look at the other pairs. We know the length of this side. We don't know the angle. We know the length of this side. We don't know the angle. So there's no way we can use the sine law. So the only option is to use cosine law. And what are we trying to find? We are trying to find the length of a side. So therefore, we might want to use cosine law in this form: a squared equals to b squared plus c squared minus 2bc over, so minus 2bc times cos A. So let's write that. A squared equals to b squared plus c squared minus 2bc cos A. Now you'll say, I don't have A, big A, small b, small c, so never mind, we can change the notation. So whatever side we are trying to find, or whatever angle we are trying to find, we call that A. So we're trying to find the length of this one here. So you might want to call that small a. This one would be big A. And then what's my B and C? Doesn't matter. You can call this B and call this one C, or call this one B and call this one C. Not a big deal. Now I know everything, so let's plug this in. So this is my unknown, A squared, so I don't know that. This is big B, this is small b. So 103 square plus c square. So side, the length of a side C, big C, small c, so this is 73 square, and then minus 2 times b times c, this is my b, so 2 times b times c, and then times cos angle A, 66 degrees. Okay, so quickly punch this into your calculator. If you do that, you will end up with 9,821.494 something. Is this my final answer? I hope you will say no. Why? Because if you look at this, we are talking about a square. So that means in order to find a, what do? We take the square root. So that's a square. So therefore, you take the square root, you take the square root. I should have been showing you this. You all should be able to figure it out. Square root and the square cancel out. So if you punch that in, so that means a is 99.1. Or maybe we should keep that to the nearest whole number because there's no decimal. So maybe I should do this 99. And of course, there is a unit. The length in this example is millimeters. So done. Okay, next question. Okay, so this one here, if you look at this, we do have A, B, and C, but then the problem is the side we are looking for, which is this one, is not A, right? So if you want, you can stick with the notations they used here, but for me, I am going to change the notation so that I don't have to keep track of which one is now which. So I'm going to change this to A. What about my B and C? Doesn't matter. If you want, keep this as a C. That's what I'm going to do. And then change this one to a B. Because if you look at this one here, we are missing some angle, so we cannot use the sine law. And this is definitely not a right angle triangle, so there's no way we can use SOHCAHTOA. So again, we can use the cosine law. So since we are looking for the length of side, so therefore we use this form. A squared equals to b squared plus c squared minus 2bc cos A. So I'm looking for this side here. Okay, which is this. So my B is 75, my C is 30. So 75 square plus 30 square minus 2 times B, which is 75, and C 30, and then cos A, which is 115 degrees. Okay, so quickly plug all this in to your calculator, then you'll see that A squared is 8,426.78. So again, take the square root on both sides. So that would give you, in this case, if you round it to the nearest whole number, because these are all whole numbers, so your answer would be 92. In this case, the length are measured in meters, so 92 meters. So 92 meters. Done. Okay, next question. Hope you still remember this term, math literacy. Solve means find everything. Find everything. Whatever you don't know about in the triangle, you find that whether it is the length of a side or angle. In this case, you know the length of this side, and this side, but you don't know any of these angles. So that means obviously we want to find this, and that. So which angle do we want to start off with? You have 1, 2, 3. From experience, it would be better off to find the largest angle first, which is in this case this one here. Why? If you recall last day's lesson, we talk about ambiguous case. So if we start off with the largest angle, then we don't have to worry about the ambiguous case. Alright, so notes here. So find the largest angle first. If possible. Alright? As I said, in this case, we don't have, once we get the largest angle, in that case, we don't have to worry about the ambiguous case because the angle we deal with is already obtuse. So, if you look at this case here, we are trying to find an angle. So, if I were you, I would definitely not using this form of the cosine law because that would be I mean, there's nothing wrong except that once you plug in small a, small b, small c, then you have to solve for a by doing the inverse cos. So why would you want to put yourself into this situation? So if I were you, I would just use this form. Okay. Okay, so this one here, let's do this. If I'm trying to find this angle using that form of the cosine law, so I better call this A. This is my angle A. Where's my angle B and C? Doesn't matter. Angle B, angle C, or angle B, angle C, angle B, and angle C. So that means my small b is 76, my small c is 54. So cos A equals to b squared plus c squared minus a squared over 2b and c. Alright, so just plug those numbers. Okay, so b squared is 76 squared and then plus c squared 54 square and then minus a, which is 112 square divided by 2bc, 2 times b, 76, and then c, 54. Okay, quickly plug that in. Alright, so I hope you all got negative 0.469, negative 0.469298. I know you'll be thinking, what? Well, perhaps I should show you how to do this. Your calculator is stupid, trust me. So let's do this. So make sure you put a whole bunch of brackets. 76 square plus 54 square minus 112 square, enter, and then divided by, make sure you use brackets, 2 times 76 times, for those of you who did divide, you screw up. Okay, 54 close bracket, because the thing is, if you did not put the brackets here, your calculator would not know that these are all on the bottom as the denominator. Okay, so make sure you put the brackets around everything on the bottom. So enter. So that gives you what I got. Okay. Okay. then that's not the final answer because this is cos A. To find A, you do the inverse cos of the same number, negative 0.469298. Okay, so in this case, the number is a little bit lengthy. You can do inverse cos, second cos. You can either punch in the whole number again or use the technique that I taught you. Second negative here, that will give you the answer. Okay, close bracket, enter. So that gives you this. Since you want your angle to be in the nearest degree, so that means if you do the rounding, that would give you 118 degrees. 118 degrees. So now angle A is 118 degrees. Once we have found an angle, the rest is easy. If you want, you can finish the rest of the question to find the other angles, angle B and angle C, by using a cosine law. But if I were you, I'll stay away from that because the math is a little bit, hopefully not hard, but it's a bit tricky for entering the numbers into your calculator. So now, if we know this angle, this length, then we can use the sine law, use these two to find these two. Okay, so let me quickly bring the whole thing here. Okay, so let's quickly finish this. Let's find angle B. So for the sine law, I hope I don't need to comment too much about that. So in this case, we are trying to find the angle, so we put the angle on the top. So sine 118 degrees over the opposite length, 112 feet, equals this angle sine B over the length opposite to that, 76. So quickly finish this. Okay, wrong color. So sine B is equal to this. Okay, if you plug the numbers into your calculator, you should get 0.59914, and then do the inverse of sine. So angle B is inverse of that 0.5999. Sorry, I messed 19 here. We don't need that many 9. So here it should be 0.59914. Okay, so if you plug this into your calculator, angle B, you round it to the nearest degree, that will give you 37 degrees. Okay, so angle B is 37 degrees, and then angle C is definitely a piece of cake, so let me just do it over here. So angle, we know that the sum of this, and that is 180 degrees, so C plus 37 degrees plus 118 degrees gives you 180 degrees. So minus 37 and minus 118 on each side, so that will give you angle C to be 25 degrees. I hope you don't find this question too hard. It's just a bit tedious. Look at how many calculations we have done. Last question. Have a look. Your favorite word problems. So pause for a few seconds. My advice, as I always do, is to ask you guys to sketch it so that you can visualize and have a better understanding of what the question is asking. Okay, so here we go. A surveyor stands at a point north of a pond. So let's say we have a pond here. Alright, so if you want, you can call that A, doesn't matter. I'll just use S to represent the surveyor. Right, from this point to the east side of the pond, this point to the east side of the pond. So let's call this E if you want. So it is 436.7 meters. And from this point to the west side of the pond is, so this is the west side of the pond, and then the distance is 703.2 meters. The angle between the measured sides, so this side and this side, is 73 degrees. What is the distance across the pond? So from here to here. From here to here. What is the distance? If you want, that's easy. Like what we have been doing so far today, call this A, because we know this is my unknown length A. So call this A, then B, then C, or call this A, then this one B, this one C, either way. And if you're getting tired of using A, B, and C all the time, let's change the notation a little bit. Let's call this X, unknown length X. So it's still the same old. Look at this. Your unknown equals to the square of the sum of the two sides minus 2 times that, cos A. Alright, so we can still write this down here. Wrong color. So A squared equals to B squared plus C squared minus 2BC cos A. Okay, so this time I'm not going to change the notation. So whatever I'm trying to find, I call that X. And then the square of the length of other two sides, doesn't matter which one is which. So one of them is 703.2 squared. The other one is 436.7 squared, and then minus 2 times the two numbers that I just mentioned, 703.2 and 436.7. Not just that, also cos A. Okay, what's angle A? The length of the unknown side, like the angle opposite to the length of the unknown side. This opposite, so 73 degrees. So quickly punch that in. You all should get this 505,629.77, and then since this is square, so you take the square root of both sides, and the question did not mention about the rounding, so to keep it consistent with these numbers, I want to round it to the nearest tenth. So if you take the square root of this number, that will give you 711.1. And what's the unit in this case? Meters. So this is pretty much all we have for now, and this wraps up the whole trig unit. So hopefully you don't find this too bad. Alright.